Today's exercise is language lists. The exercise introduces us to the list primitives in Elixir and 2 modules for working with lists. We're continuing to explore NotebookLM for AI learning assistance. Additionally, we'll be switching to VSCode for our editor, where we'll get AI-powered auto-completion. NotebookLM has a video feature that does a pretty good job of creating presentations. With just the link from the Exercism site, I was able to click Video Overview, and after about 10 minutes, you end up with a video. Let's watch a little bit of it. I'll put a link to the full version in the description below.
All right, let's talk about Elixir. You know, when you're learning a programming language, you start with the basics, right? And in Elixir, one of the most fundamental building blocks is the list. But here's the thing, don't let that simplicity fool you. The way Elixir thinks about a simple list, well, it tells you everything you need to know about its entire philosophy. So let's pull back the curtain and see what's really going on under the hood.
So let me ask you this. What actually makes a list a list? Now you're probably thinking of it as a simple container, like a box you can just throw things into. And hey, that's a totally normal way to think about it. But Elixir has a much more elegant and frankly a much more powerful idea in mind.
And this is the key right here. In Elixir, a list isn't just a box, it's what we call a linked list. The best way to picture it is like a chain. Every single link in that chain holds its own value, sure, but it's also physically connected to the next link. So it's not just a random collection of items, it's a sequence where each piece knows about all the pieces that come after it. This brings us to...
All right, and while we're here, let's take a quiz and see if we know anything about Elixir lists. All right, based on Elixir's internal representation, what is the tail of a non-empty list? A list containing all elements except for the first one, I believe, is the answer. Let's see. Yay. Given an existing list, mylist equals 2, 3, which expression correctly prepends the number 1 to create the list 1, 2, 3? A looks good. What's the 1 prepended by mylist? That's the wrong way around and doesn't use brackets in B. C is the incorrect order. And D, it has the wrong, it's not a comma, it's a vertical bar. What's the correct recursion representation of the list AB using the head-tail notation? I'm not sure what this question's getting after. If you were trying to construct the entire list from scratch, you could say in C, let's use B and prepend that to an empty list. The result of that, then, we prepend A to the newly created list with B. I think D is also technically correct, but I think they want C here. Which of the following describes the fundamental structure of lists in Elixir? It is not a collection of key-value pairs. It is a linked list. It's not a fixed-size collection of elements, and it's not a contiguous block of memory like an array. So it is B. Which operator mentioned as part of the kernel module is used to check for the presence of an item within the list? Plus plus turns out to be a list appending operation. Equals is a match operator. In is the correct function. If you needed to implement a function that returns the first element of a list, what part of the list structure would you access? You would access, well, not the last one, that would be the last, not the first, not the tail, that's also last. We don't care about the length, we want the head. What is the key characteristic of lists in Elixir as described in the source material? They have a fixed size after creation. They may be empty or hold items of any type. Well, that's true. They can only hold items of the same type. That's false. They don't have to have one item, so I don't think that's true. And I think this is more of a reference to an array here in A, so I think they want B here. It could be empty or it could hold items of any type. If you have a list, my list equals Haskell and closure, and you need to get the list closure, what operation are you effectively performing? You are filtering the list of elements other than Haskell. Well, there is a way to do that. You are retrieving the tail of the list. That could be true too. That's not the head of the list because the head would be Haskell. Reversing the list and getting the new head. Well, you could, but I really think they're looking for B here. Let's see. Right. Yay. All right. Now let's turn our attention to switching to VS Code for an editor. So if we go look at an exercise here in Exercism, in previous episodes we've been using the editor in browser editor. We're going to work via the CLI, and the instructions for solving exercises locally are here. You have to install a CLI or command line interface, and then once you've done that, you can use this command to download this specific exercise. So here are the instructions: how to download it, how to install it. Using VS Code is definitely better than the in-browser editor, but it is also a step up in complexity. I've already downloaded the language list exercise using that command line. What you see here on the left is the Explorer view, which shows all the files in the project. There are 4 you should know about. First is the README. This has the instructions that you would see on the website. In the lib folder, there's the language list. This is the beginning source code that you would have seen in the in-browser editor. Here are the tests. You would not have had visibility to these before, but these are the tests that run in the cloud. And then at the very end, you'll need this help file because you're going to need to know how to submit your solution. It also helps you with things like how to run the tests and so on. So let's go back to the instructions here. This is the information about lists themselves, how to construct them, how to work with them. And the first exercise function is to define a function to return the empty list. So if we go into our source code, here's the new function, and want to return the empty list. Now in our terminal window down below here, we want to run mix tests. Now this ran all of the tests, and you can see, of course, a good bunch of them are failing. You can run just specific tests by giving it the only flag, and we want task ID 1, and I'm getting that from that this new test here is tagged with task ID 1. And there we can see that the new test is passing. Right? 12 tests, 0 failures, 11 were excluded because this is the only one in task ID 1. The others have task ID 2, 3, 4, and so on. All right, so the new function is working. Now we can go back to our README for the instructions. We want to add a language to the list. So the add function takes 2 arguments, the language list and the name of the new language, and it should return the resulting list. So here we have our add function that takes the existing list and the new language. The idiomatic way, oh, there we got autocomplete for free. The idiomatic way to add a new entry to a list is to prepend it with the vertical bar. So we could now say, is this right? We'll run for task ID 2, and we see that we got 2 tests passing. So that's what we want. Define a function to remove a language from the list, and not just any language. It wants to just give you the list, and you should return the list without the first item. So there's a few ways we could do this. And another way to put it is that it's asking for the tail of the list, right? It's asking for anything after the first one. So one way to do that is this, where this is the head, the first item in the list, and then the tail is the rest of the list. We can assign it like this. This breaks out the head. It deconstructs it, I think is the word, between the head and the rest of the list, and returns just the tail. So task ID 3 had the remove functions in it. Those are passing. Define a function to return the first item in the list. All right, well, this is the opposite of what we just did. And let me show you a different way. You needn't actually do this as a separate line in the code. We can, right here, as an argument, we can say match the argument passed in to the head and ignore the tail and just return the head. There is a little bit in this instruction here that says assume that the list will always have at least one item. So there's another way. So this would fail if there wasn't anything in it. Right? You could also have written this to use the kernel function, HD, head, of the list. And this will work fine so long as there's one item in there. If there aren't any items in the list, then this would raise an exception. And because it's in the kernel, we don't actually need to say that. We can just say, give me the head of the list. Okay. Well, I can guess the next one is going to ask to return the length or the count of items in the list. There is a kernel function called length. Takes the list. And that is the simplest way to get that back. And the last exercise is to determine if this list includes a functional language, and not just any functional language. It wants to know if Elixir was in the language. So where did that go? There, Elixir. Okay. There is a macro, actually. It is in, well, that's a nice answer there, autocomplete, but it's not what we're looking for in this exercise. There's a macro called in. And what this is basically calling the kernel in function given the list and the element. The way to actually express it would be this. Nobody would actually write kernel in. Oh, which way do you want? Left, right. So right, if the left is in the list. Okay, so people would write Elixir in list. And if it is in the list, this would be true. If it's not in the list, that would be false. All right, let's run all the tests to be sure. 12 tests, 0 failures, perfectly good. Then, like I said, what we would need to do next would be to go to the help file for how to submit our solution. You use the CLI with the action of submit, and you give it a path to your source code and submit that up to the cloud. Well, I think that was awesome. We saw NotebookLM's free way to get a presentation on the exercise, a quiz on the Elixir feature to be learned, and some autocomplete help from Copilot and VS Code. Join me next time for the guessing game exercise, where we learn about how multiple functions with the same name lead to simpler, more elegant code.